prime and nth prime. So the code here, I'm not going to derive from first principles. I'm going to show you when I run it that in fact it works, and it said okay, so it works. I want to just talk briefly about what's going on. So in the previous examples, we basically use recursion to work our way down. Fib of 4 is fib of 3 plus fib of 2. 5 factorial is 5 times 4 factorial. In these examples, we're going to turn around and count up. So when I ask if a number is prime, when I ask if n is prime, I start counting from 2 up to the square root of n and check if I found a factor. To do this, we're going to provide an optional parameter. Factor is an optional parameter. So I can call isPrime and do not provide a factor, and if I do that, it will start with factor of 2. That gets the process started. And then each time we recurse, we'll just add 1 to it, to do 2, 3, 4, 5, and so forth. And in this way, we're going to count upwards. Our base case, because of that, isn't when factor is 2, it's the other way around. It's when we've gotten larger than the square root of n. And it turns out there's another base case. As you're counting up, if you found a factor, you're done. So just return false. The reason these are called base cases is it's a base case if you do not recurse in that case. And naturally, in each of these 3 cases, we're not recursing. So those are our base cases. It's the recursive case if you do recurse. We have one and only one recursive case. A number is prime if for a given factor, if it's prime for one larger than that factor. I'm not a big fan of this because I don't think that what I just said makes a lot of sense intuitively. I don't think this is a great use of recursion, frankly. Having said that, we're demonstrating that you totally could do it recursively. And the same exact trick basically is applied for nth prime, where we count up. But now we actually have 2 counters going on because nth prime requires 2 counters. Your guess has to count up, and your number found also has to count up, which just means you have 2 with default values because, of course, when you call nth prime, you don't provide those values. You only say, I want the 4th prime, the 7th prime. And then these would be initialized at 0 and count upwards. So this is more an example of what could be done, I believe, than what should be done. But certainly it's a good demonstration that you do not need iteration at all. You don't need loops. Anything that could be done with loops can be done without loops using recursion. But again, I'm not sure this is the most intuitive example.